So here we have a very interesting statement. Let's eat grandma. Well, if you just say it like that, it sounds that we're all starving, grandma's not contributing much, and it's time for grandma to, help us all out. All right, which is kind of icky and yucky, and we're going, what? What if we were to put a teeny tiny little mark? An itsy bitsy little mark, would that change anything? Yeah. Now it becomes, let's eat, grandma. Which there still could be some question. It could be, let's eat, grandma. Or it could be, let's eat, grandma. There's still various ways, but at least that improves a thing. So one teeny tiny little mark all of a sudden opens up brand new ways of interpreting this statement, right? In the same way, if we consider a balanced equation to be a statement, a story, teeny tiny little marks. In our case, they're not going to be marks, they're going to be letters. Little bits of information can also give us critical knowledge that we need to understand what's going on. All right? Well, here we go. Number one. What other pieces of information can be used with a balanced equation? We can find out its phase. I'm not talking about happy face or grumpy face or constipated face. I'm talking about PHASES, the phase of matter. For example, what are the phases of matter? We can put a little S there. Guess what the S will stand for? Solid. And the L will stand for? And the G will stand for? All day long I've been saying G, and no one's ever challenged me on that. Do you know why I say G? Because what is GAS? GAS. It is gas. It's not jazz, is it? Is it the color green? Is it a giraffe? No, it's not a giraffe. It's a giraffe. And it's the color green, and it's gas. I am being, unlike you English-speaking people, me, English is my second language, I'm just being consistent. G is for gas. What about AQ? Now that one is one that you are not familiar with. AQ stands for aqueous. Okay, so that wasn't very helpful. Aqueous means dissolved in water. That means what happens when you take some salt, which is a solid, and put it in water and it disappears. Well, according to the law of conservation of matter, that it really doesn't disappear. It actually just comes apart. It dissolves into particles so small that you can't see. So when something dissolves in water, whether it's a solid, a liquid, or a gas, we say that the water is now an aqueous solution. It is aqueous. Aqueous. Okay? So, how do you know if something dissolves in water or not? Well, you ask yourself two questions. Does the sentence, because a lot of times the question comes in the form of a sentence. Does the sentence refer to water, the presence of water? Or better yet, does the sentence use the word solution? If it says solution, like sodium chloride solution, then it's aqueous. It's aqueous. But more important to you guys, what does it say on the solubility chart? Because now when I tell you every day, when the warning bell goes off, I say, hey, take out your periodic tables because you'll need them. Okay? From now on, I will be saying, hey, take out your periodic tables and your solubility charts because you will need them. How does a solubility chart work? Well, look on top. Look on top and you'll find a bunch of anions, negative ions. On the bottom, you will find a bunch, on the side, on the left side, you will find a bunch of positive ions. So usually these compounds are a positive plus a negative ion. This is as easy as just looking it up on the chart, and I'll give you an example here in a second. Now, you won't find any of the alkalis. The alkalis are the first column elements, like sodium, lithium, potassium, cesium, rubidium. They're not there. You know why? All of them, 100% of them, are aqueous in everything. In other words, they will always dissolve. They always dissolve. You will also not find the negative ion nitrate, NO3. NO3. So, Caterina, when you're doing these things and you start looking for nitrate and you can't find nitrate up here, should you freak out? No. You should remember, hey, he said something about something always being aqueous. So you look down at the bottom of the chart, and do you see it? NO3 is always aqueous. So no freaking out. Okay? Now people ask me, well, what about if it's a blank? I'm not going to give you that one. What about D, Mr. Moreno? I am not going to give you that one. Okay, I'm only going to give you the ones that are either AQ or S. AQ means I have dissolved in water. S means I cannot. So, you drop crystals from the following ionic compounds into water. Will they dissolve? AQ. Or will they not? Solid. All right, this is how we do this. Silver. Find silver. Oh, there it is. Please don't write on your solubility chart. Just kind of, put your finger on silver. Now, let's find chloride. There it is. All right, so let's move over until they intersect. And what does it say? S. So the answer is S for solid. All right. Elizabeth, try this next one. Sodium. Let's see. Sodium. I don't see sodium. I am freaking out. I am freaking out right now. Ah! Okay, are you freaking out with me? No, she said no. She didn't say sure, she said no. Okay, and why aren't you freaking out? I don't see sodium there. That's right, because at the bottom of the chart, sodium is in there, and the bottom of the chart is saying sodium is always AQ. Good job, Elizabeth. All right, let me erase all this crapola. Jonathan, which is the long form of Sean. Jonathan. Iron. Well, which iron? There's two irons. There's iron 2, or which one should I use? 2, even though there's a Roman numeral 3 there. 3. 2 or 3, which one? Okay, because of the Roman numeral. So we're using this one, and what's the next part of it? PO4. Oh, there it is. So, what do we do? What is it? Nice, Jonathan. Mani, copper 2 chloride. So I see 2 coppers. There's copper 2. Chloride. What do you think? 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 AQ. Very good. Very good. Very good. All right. So, usually when we're dealing with these kinds of reactions, we are usually dealing with two aqueous solutions that we pour together. When that happens, we call, and crystals form, we call it a precipitation reaction. A precipitation reaction. Wow, I've heard that word before, precipitation. Have you? When you hear of something precipitating, what do you think of? What? Fog? Falling. Falling. Okay, what is falling typically when the word precipitation is used? What? Rain. Okay, rain or snow or even hail. If it's liquid or solid and it falls from the sky, we call it precipitation. Okay? The reason why this is called precipitation is if you pour two liquids together and all of a sudden crystals emerge and start falling, like Alia said, falling, then we call that a precipitation too. And we call the solid a precipitate. A precipitate. Okay, so let's now merge what we've just learned with what we learned yesterday. Here we go. First of all, let's balance it, and then let's determine whether a precipitate, a solid, is formed. Kayla, here we go. Here we go. Here we go. How many NAs?
One.
How many NAs?
One.
How many OHs?
One.
How many OHs?
3.
Uh-oh. So what do we multiply this by in order to get 3 OHs on that side too?
3.
Okay. So now we have 3 OHs. Unfortunately, you thought you had already fixed sodium, but what have we now done to sodium?
Multiplied by 3.
Right. So now this sodium is wrong. So what do we multiply that sodium by in order to get 3?
3.
Very nice. Very nice. How many irons?
1.
How many irons?
1.
How many nitrates?
3.
How many nitrates?
3.
Ah, so it all worked out, didn't it? Good job. Good job. So 3 sodiums, 3 sodiums, 3 hydroxides, 3 hydroxides, 1 iron, 1 iron, 3 nitrates, 3 nitrates. All right, good, good. Brianna, sodium nitrate, look it up on the chart. S or AQ? Yeah, because neither sodium nor nitrate is in that chart, which means it's automatically AQ. What about iron 3 and hydroxide? By the way, in case you're wondering, iron 3 hydroxide is typically what we know of as rust. So if you ever cut yourself deep enough and really bright red blood bubbles up, then first of all, you're in trouble and you need to get medical help immediately. Second of all, that bright red is caused by iron 3 hydroxide. Okay, normally it travels as just iron 3 oxide, which is that crimson color. All right, nice job, you two. CJ, how many BAs?
1.
How many BAs? How many NO3s? How many NO3s? Uh-oh. What do you do? Okay, you know that's going to mess up your Ks, right? How many Ks? How many Ks? Oh, actually it fixes the Ks. How many SO4s? How many SO4s? I think you did it. I think you did it. Good job. All right, Yasmin with a Y. Look up BaSO4. Ah, it's an S. How about KNO3? Actually, it's not even in the chart, which means it's AQ. All right, so why is this one practical? Has anyone ever had a barium cocktail? Well, if you had a CAT scan for your gut, you got a barium cocktail. Who's ever had a CAT scan for their intestines? Do you remember drinking this horrible youchy stuff? They sometimes put color in it just to make you feel better, but it's still, it feels like you're drinking chalk. Okay, that was barium sulfate. Now barium sulfate is deadly to you. So if you're wondering why did they give it to me? Well, because barium sulfate cannot dissolve inside of you. It is insoluble. It does not, it stays a solid. So your body can't extract it and get it into the circulatory system. And barium is a huge atom that readily absorbs X-rays. So as it coats your small and large intestines, it stays on the surface, and when they X-ray you using CAT scan technology, they're able to see where all the barium is, and what the barium does is as it coats all the curves and bumps and stuff, you can now see all the curves. Basically, they're looking for an obstruction or something that's unnatural. Okay? So they will give you something that is deadly to you in order to figure out what's wrong. Because, the way they think of it is it's highly, 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 highly unlikely that's going to get inside of you and kill you. But whatever is obstructing you is definitely going to kill you right now. Yes? Oh, that was fun, wasn't it? Okay, it comes out eventually. Because remember, you got all those little tentacles that are constantly pushing things through your gut. Okay, so eventually it just kind of accumulates deep inside there, and then you go, ooh, I need to go. And then you go, and you go, and you go, and you go. And it's really kind of go-y type stuff. Jasmine, a little better now? Now you understand what happened? Barium sulfate. Okay, so let's see, who was that group with Yasmin? Over here with Caden. How many CUs? How many CUs? How many CLs? How many CLs? How many PBs? How many PBs? How many NO3s? How many NO3s? Wow, that was the easiest one you've ever done. All right, Eva. What is it? Copper 2 nitrate. Look it up on the chart. AQ and PbCl2. That's your S. Good. All right, Brennan. So this one explains to you why these things could be so critical. For example, if this was the case, if you were mixing solid copper 2 chloride with solid aluminum pieces, then nothing would happen. Nothing. They would just sit there for all eternity going, what? But if you were to mix dissolved copper 2 chloride with aluminum, then things would happen. Copper would form. Okay? Brennan, how many aluminums?
One.
How many aluminums?
One.
How many coppers?
One.
How many coppers? How many chlorines?
Two.
How many chlorines?
Three.
Oh. And I don't think there's any way of making 2 become 3, is there? So we're going to have to do something to that 3. We're going to have to multiply it by something that gives you an even number. And that something is Now, keep in mind, you just screwed up your ALs, right? So, how many CLs do you have now? And how many CLs do you need? You have to, what should be in that blank? 3. Okay, I think you've now messed up your CUs. So how many CUs? How many CUs? How many ALs? How many ALs? All right, now this one's a little harder in that copper by itself is not on your chart. That's because I'm expecting you to have a little bit of common sense. Lily, the metal copper, what is its natural form? Is it a solid, a gas, or a liquid? Okay. Now, the AlCl3, Lily, you can look up. What is AlCl3? All right, so any questions on this? Here is what you need to do for the remainder of the period. Finish the worksheet 8.2, but if you've not finished your balancing equation activity, go finish that first. And then about 10 minutes, no, that's it, about 10 to 15 minutes before the end of the period, we will, if we have that much time, we'll do a quizzes. We'll do a quizzes as a class. All right? So, finish. Oh, we have 7 minutes? Then finish. Those of you who have 8.2, but you had to finish what's in the lab, don't worry. I'll give you time tomorrow to do 8.2. Okay? So those of you, I'm going to collect those cards. So go finish now. Those of you who did not finish, go finish now.